Hello and welcome to our session, How to Integrate ACC into an Enterprise System Landscape. My name is Christian Gartner. I'm Solution Architect at ANDRITZ. JR will introduce him in a minute. And today we want to talk about how we at ANDRITZ automated the document and data workflow between various engineering systems and Autodesk Construction Cloud, as well as from ACC to DMS and other systems. We will start with a brief introduction into our company, then the usage of APS and ACC at ANDRITZ, and then we will start with how we integrated ACC in our system landscape, show you the process and the workflow, and following by an insight to the technical architecture, and then we will finalize with lessons learned and a conclusion. Who we are and what we do. We are an engineering company developing large-scale, state-of-the-art engineering projects. For us, it is important to support our customer through the entire life cycle of the plant with our services 24/7. And with many products we deliver, we are enabling our customers to drive their green transition to become more sustainable. At ANDRITZ, we are separated into 4 business areas. Pulp and paper provides machines and plants for producing pulp and paper, paper tissue, toilet papers. Metals offers system for producing several types of steel, presses, press lines, a big percentage for the automotive industry. Hydropower offers electromechanical equipment for hydropower plants and turbo generators. And environment and energy builds solutions for multiple industries and processes such as water, wastewater management, recycling, battery-related mining, and so on. ANDRITZ is an Austrian-based company with around 30,000 employees. The headquarters is in Graz, but there are over 280 locations in over 80 countries around the globe. Now, let's start with usage scenarios of APS. At ANDRITZ, we can divide it into 3 areas. Custom solutions, where we build products based on APS. The most 2 prominent examples are our Metris spare parts catalog and Metris digital plant documentation. There are Autodesk University sessions available online if you want to have a more detailed look into that one. Next one are integrations. We will talk about that in the remaining session, so let's pause it for a minute. And last but not least, automation. There is a need to not only transfer data from A to B, also to process them, to either extract information from CAD drawings, for example, or to remove details to protect our intellectual property. That was now just a brief overview, and now show you how we use ACC at ANDRITZ. Most obvious, main focus for us is project collaboration. Having all relevant project data and documents from various systems accessible in a central platform and providing collaboration workflows. But in addition, ACC acts as a data and document management hub for our customers during operation phase. At ANDRITZ, we offer several digital twin solutions. If you can go back once, please, Chair. Like Metris Digital Plant and Metris Extended Reality, where people either virtually, based on a smart 3D model, or in real life, via a head-mounted device, walk through their plant and access context and location-specific information. Initially, that was based on as-built data, but we quickly learned from our customers that they want to manage their data by themselves and keeping it up to date. Therefore, meanwhile, we offer ACC as a central data and document management hub that feeds our digital twin solutions. But now, let's start with the integration. As mentioned in the beginning, ANDRITZ has multiple business areas. Each of them have their own engineering stack for the different disciplines. As an example here, within pulp and paper, the mechanical engineering, mainly via Autodesk products, AutoCAD, Inventor, Board, plant engineering, 3D plant engineering, mainly Aviva, E3D, and process engineering, Comos. And data of all of these systems need to be available in ACC for collaboration. And in addition, there is also a need to send documents from ACC to our enterprise document management system, for example, for legal reasons, for archiving, and sometimes also to send it to customer systems. For example, customers have their own ACC environment. And we started with ACC using the desktop connector, but we quickly learned that there is a need for automated workflows. Already our first bigger projects consisted of more than 30,000 documents with multiple versions, revisions, different status, and also additional metadata that were needed to have access in ACC. And maintaining that manually, uploading that manually was not acceptable because it's really time consuming and also prone to errors, to forget to share the latest information, for example, or the latest version. How we did this integration or how this started is that within the source systems, we can flag projects or documents as ECS relevant. And maybe since I haven't mentioned that at that point, at ANDRITZ, the service where ACC is the main component is called ANDRITZ Engineering Construction Service. Therefore here, ECS relevant. You can also see it as ACC relevant. And then all these flagged projects or on document level, depending on the workflow in the source systems, these documents are sent to ACC. That could be like we have in mechanical engineering, there's a release process with work in progress, then a document is approved, released, that we hook into that, and as part of the release process, a document gets released and we automatically upload it to ACC. Or as done in plant engineering, every night the latest 3D model is exported via Navisworks and then uploaded to ACC. But independent of that, there is always the possibility in all the systems on demand to say, now this document I want to send to ACC, click on the button and then the transfer is initiated. But before we started with the implementation, we thought about, okay, what are our main design principles for such an integration? And the first one is no ACC specific business logic within the source system. Really avoid duplicating business logic in the different sources that is complex to update. What does this mean? A source system does not know anything about ACC. Projects, target project, target location where the document should go to. Their business logic consists only of providing related data from their source and the trigger for a document submission. Then having a central overview of all these integration jobs, including status and all the relevant information. Also important for us is the possibility to re-trigger such an integration job at a central place without accessing the source systems. Just as an example, an engineer in Word on demand wants to send a document, click on that button and then continues to work. And along the integration, the upload fails because of a configuration issue. And we really want to avoid that the engineer needs to do that again. So our support can fix the configuration issue, re-trigger that without accessing the source system. And now, JR will explain you in detail how we achieve that. Handing over to you.
Thanks, Christian. So I'm Vivanshu Aynes Jr., but you can call me JR. I'm the technical lead in ANDRITZ, specifically in the engineering and construction service. So to continue, we started this journey by providing the core functionality from source systems, and it is to submit documents and metadata to ACC. And you've heard earlier our design principle, and following that, we implemented an integration layer, abstracting the direct integration to ACC API. Our integration layer accepts the request, validate it, provide an identifier, and this identifier can be used by the source systems to track their submissions. What it means then on the source system side is that they need to integrate to our integration layer using a generic payload schema. The generic payload schema is standard and consistent across different source systems. It includes essential details of the project, the originating source system information, the document and its metadata, and the location on where we can find this document. For the document location, our integration support documents coming from on-premise network using file shares, and also coming from the cloud using HTTP endpoints. The benefit of this approach is that the source system is abstracted to any ACC API changes. And it also prevents workload disruptions in the source systems. So it doesn't need to wait for the document to be finished. And it means that engineers can work on other workflow in their source systems. The next topic is about the central mapping logic. We consider this as the heart of our integration layer. Here, we make sure that the documents and metadata submitted are mapped and will flow to the correct target location in ACC. Based on the source system package payload received, the mapping logic will start narrowing down the list based on potential projects in the target destination applicable based on the payload passed. And then the mapping logic will then start to match the folder information or the source path. We up the game for the logic and we make it more smarter. It not only map a source folder to a target folder in ACC, but also applied a mapping logic wherein a folder mapping can be also mapped to a metadata-based mapping. Example of this, that when you see here, the document needs to flow to one folder coming from source system to multiple folders in ACC. So if you can see here, if the metadata of the document contains an AES status of in work, then on the folder mapping, there should be a corresponding work in progress folder, and this document will flow on that one. While a document with an AES status of released will then flow to a released folder. After the folder level mapping, we also map the metadata corresponding to the document. And this will flow to ACC custom attributes. This will ensure that the accurate transfer of document and its metadata associated to it. The document upload to BIM 360 or ACC. At this point, the document submitted from source system is now prepared and ready. We have queued them with identifier. We know where it will land in ACC using the mapping logic. And now it is time to upload it to ACC. In actual technical terms, this is the time we call the ACC API. Here, Following still the design principle, we implemented it again in a generic way using a generic schema called the BIM upload package. We also queued it, provided an identifier, so we'll be able to track it, and also have a functionality to retrigger it if in case it errors out. Then you might ask, then what's the difference between a source system package and a BIM upload package? Well, a source system package is closely aligned to the source system schema, while a business upload package is more structured towards an ACC data structure. Implementing it this way allows us to provide additional functionalities before the actual upload to ACC. One of the functionality we have is the ability for the document to be changed based on certain metadata. Actually, this functionality is originated from a limitation in ACC mobile when we are searching documents. It actually only allows us to search document name and excluding the certain metadata. Hence, when we implemented this functionality of metadata-based file naming, then we can now search in mobile using just the document name, since the metadata is already included there. Another functionality that we added before the actual upload is that we added a functionality to upload once and copy it to multiple target locations in ACC. So technically, it's just using the same version of the document and copy it to multiple folders in ACC. Moving on, we now come to a point where the core functionality to submit and upload documents in ACC is done, and it's actually successful already. But we figured we can offer more to reduce manual efforts to engineers. This then reduce engineering workload hours via an automation. Another thing is that we want to protect our intellectual property and do some post-processing as well, whether to extract information or hide information to the uploaded documents. We're able to do this via the Design Automation API. So here, the workflow is to prepare the CAD app bundle with multiple commands already included in it. We then use our mapping logic, extend it to include the post-processing logic. And here you can see an example wherein we set a post-processing for a specific project and for a specific document type. So if we receive a request on this project and with a specific document type of drawing, then it will then post-process with a specific task or command of task 1 and task 2. Then access job queue and manage mappings. Again, at this point, we have an end-to-end functionality already in our integration layer. On the source system, when they submitted the document, we're able to map them using the mapping logic, and we uploaded the document already to ACC, and also we extended the functionality with some post-processing, reducing the engineering workload hours. So at this point, we're good. But we felt that there's something missing. If there's a new project coming in, we have our prepared script. We create the project mapping by our script to our database. And we figured we know we can delegate this to this project setup to key project users, and we figured the need for the user interface. So the user interface must have a way for us to manage project mapping configuration. So it will be easy for the users to do that. Also, it allows them to view their submission, the details, and if it errors out, they should have the ability to retrigger the jobs from there. I can then show you how it looks like using our web interface. So you see here that we found an error in one of the submissions. We figure out what caused the error. We see the details of the source system package, and we know that this is coming from this particular source system. Okay, then if I'm the key users, I'll go to the configuration, find the root cause of the problem. This is coming from ADMS, and found out that there's no folder mappings available on this one. Okay, I can fix that. I'll just provide the necessary information here and be able to click Save. Doing this, I know that I can then retrigger the flow and be able to do that via the user interface. Once I retrigger the flow, this will then pick up by integration layer and will mark as pending and will flow again to be processed. All right. So at this point, again, documents are readily available in ACC for collaborations. They can use issues, they can use markups, and other functionality. But we know documents in ACC is not the final resting place, right? But we know that the documents are the source of truth. Integrations can happen after ACC, and there are particular use cases that we have for this one. So one of that is to flow documents from ACC to the other document management systems for legal purposes and also for archiving purposes. So that's one. Another use case is that we are using is that to outbound this document in ACC to another external systems. And then to bridge these documents and metadata to another supplier or customer's ACC, because it's possible that our customers also have their own. Here we adapted our integration layer to use this outbound workflow. We use ACC reviews and transmittal to be able to work around on this one. And we know this is not without limitations. We still need human interaction in ACC to trigger this workflow, this reviews and transmittal. Also, specific recipients are needed to set up for us to be able to map this workflow to the intended functionality. So for transmittal, we are actually using a service account, add them in the project in ACC. And whenever we create a transmittal, we need to add that service account as the recipient of the transmittal. While for review, we can then know and identify based on specific workflow ID. We then track these workflows or via reviews and transmittal via data connector API and retrieve the information from there. Then we build the document and related packages based on that. We know that there's a beta release review API, and then we're transitioning it towards using that. But for transmittal, we're still waiting for a transmittal API so we can obsolete our data connector usage. Well, processing this follows the same design principles. We have it in a queue, we map it via our mapping logic, and then upload it to destination or external systems. The technical architecture. So after showing you the flow of our integration layer, we are now showing you the approach of how we're able to come up with our technical architecture landscape, and also provide you some insight why we did decide on adopting several resource based on our technical architecture. We adopted early on a cloud first and API first approach. This is actually allows us to be flexible towards future integrations and also be more efficient in scaling. So if you notice, for our hosting capabilities, we are using Azure App Services. This hosts both of our API and the ECS web interface. For specific event-driven tasks, we are actually using Azure Functions, which covers event-based trigger, time-based if you have schedule, and queue-based triggers. We are a .NET developers mostly, and C# is our main technical stack. And using this, it allows us to use Linux-based resources and making sure that our resources are more cost efficient. Talend, we use that as a primary orchestration layer, allowing us to access securely our on-premise resources and as well our cloud infrastructure. If you notice, we are using Autodesk Platform Services such as ACC API, Design Automation API, Authorization and Authentication, OSS, and Data Management API. We are heavily using Power BI for our data visualization, and we know for a fact that ACC have solid integrations with Power BI. We can directly get the data coming from ACC from there, and also can embed Power BI in ACC. We have some tools. We have some Python scripts, and we also automated some Excel implementations as well. As mentioned, these are the deciding factors, and it's to make it more cost efficient and making sure that we're adapted to future changes in our cloud infrastructure. Then we're moving on to lessons learned, and I will then switch back to Christian.
Thank you, Chair. Within this journey, the last years, we learned a lot. To mention a few important topics for us, let's start with the first one, initial lack of user acceptance. As mentioned in the beginning, so we started with a desktop connector approach where people manually uploaded files to a specific project, to a specific location, and they were used to that process because previously we used a network share. And then introducing something where you reconfigure a mapping based on your structure in the source systems required, and we underestimated that, intensive support and training in the beginning. We know this process is much more efficient than the manual one, but still initially we underestimated that effort. What helped us here is to establish a standardized folder structure for new projects and harmonize it as much as possible, because then we can take over the configuration and there is no need to do it again and again for each project, just to adapt the things which changed. And what JR also have shown, the self-service tool where people can configure their mappings by themselves. Even if we are still in the beginning of that configuration tool, that helps already quite a lot. Second topic is we explored or we tested ACC Connect, which is Brockato in the background, so as an iPaaS solution. And our findings there is, so of course, for simple workflow, it's quite good because the orchestration, queuing, monitoring, logging, and so on is provided out of the box. But this low-code, no-code experience quickly becomes confusing and complex. So whenever you either have workflows that are not that simple anymore with multiple options, or you anyhow have development part of your team, of your project, then I would suggest, to do it by your own. What we did, we moved away. We use Jupyter notebooks for automatizing the admin workflows. JR mentioned that already. We have Python libraries, which also now our admins via Jupyter notebooks, which is quite easy, can just run them. And there we are much more flexible. The third one, JR mentioned that we use the data connector also as a workaround for this missing transmittal API. And here, our learning definitely is there. We had no other option, but use data connector only for non-time critical workflows. And wherever there is an API, prefer the API, because we run a logic to call the data connector quite often, and there are always delays. Sometimes you get errors. So we have a lot of delays for time critical workflows. So only use it there if you do not have another option. And what we also learned, and as a learning, you should consider already from the beginning, always check if there is a public API available. Same again here for transmittals. So there is an API, but it's not accessible for the public yet. So there are some functionalities which you cannot interact via API as of today. Transmittal, we are talking with the product development, so it should come. With that, I would say we can come to our conclusion. A short wrap up. We started to give an introduction why we see a need for automated document and data workflow between ACC and other systems. Then also our design principles. So really important for us is to not having business logic, our ACC business logic within the source system, having a centralized integration and mapping logic where we can do that centralized and reuse it. JR also gave an insight into design automation to reduce engineering workload, which helps a lot. Then also JR have shown the web app for self-service, to have access to the queue, to see what's going on, to allow our users to do things by themselves. And then finally, JR gave an insight into technical architecture, which components we have, how we set it up. And with that, we have to say thank you. I hope you learned something, or at least got an insight that helps you for your project. Thank you.